starting early. Okay, starting up the live stream today on a beautiful Sunday. A little bit of a rain. Waiting for audio checks. Sounds good so far, I think. Okay, cool. We are all set. We are ready to go. All right, welcome back to the live stream, folks, where there's usually just one person watching. But again, these are these working sessions where I'm just compiling this study guide for this upcoming AMIA AHIC exam for the next 95 days. So we're just going to do these working sessions. Today, I'm going to try to cover 2 sessions in the first hour, and I'm a little behind right now, so I'm going to cover another 2 sections in the hour afterwards. So in this one, we're going to do sections 8 and 9, which is basic database structure, data retrieval, and analytics techniques and tools. And then the next one is going to be basic systems and network architecture. So let's go ahead and start with basic database structure. So let us begin with a nice Google search. Off the top of the bat, I'm sure most people are familiar with like hierarchical and relationship type databases. So I wonder how many other database structures are there? Let me see, what is it? Basic database structure. So types of database structure. Here we go. This looks promising. What is a database model? Database model shows the logical structure of a database, including the relationships and constraints that determine how data can be stored and accessed. I need to start up Zotero too. Individual database models are designed based on the rules and concepts of whichever broader data model the designers adopt. Most data models can be represented by an accompanying data model. So yeah, this is fine. So this is like hierarchical and relational. So these looks right. Database. There are many kinds of data models. Some of the most common include hierarchical, relational, network, object-oriented, entity, relationship, document, entity, attribute, value, star, schema, the object relational, which combines the two. So this looks pretty solid. We can probably go through this. I'm not as familiar with these other database models. Let me just check one more source to see if there's anything else that I might be missing here. Database structure and design. Let's see. Was this the same resource? One-to-one database structure. This doesn't look like what we're looking for. We're looking for the different types of basic database structures. Let's take a look at this one. Nope, behind a paywall. 10 common database design. No. This might look good. Creating record type. Okay, nope, that's not what we're looking for. What is the structure of a database? Give an example. Nope, that's what we looked at earlier. How to build it. What are the different database schemas? Let's take a look at this one. There are like different types. There's like different ones in this one. Maybe I'll just use a combination of these two, and we'll get the gist of the different databases. So let me go ahead and start with this one. Let me go ahead and cite. This one's called database schema examples, and then this one is database diagrams. Okay. Type of database model. So I'm going to copy this. Come on. Oops. without formatting. Okay. And we're probably gonna read through some of these because I'm not as familiar with these other models. But let me go through here. Relational model, the most common model. The relational model sorts data into tables, also known as relations, each of which consists of columns and rows. Each column lists an attribute of the entity in question, such as price, zip code, or birth date. Together, the attributes in a relation are called a domain. A particular attribute or combination of attributes is chosen as a primary key that can be referred to in other tables when it's called a foreign key. Each row, also called a tuple, includes data about a specific instance of the entity in question, such as a particular employee. The model also accounts for the types of relationships between those tables, including one-to-one or one-to-many and many-to-many relationships. This is probably fine like this. I feel like a big part of this exam is honestly going to be just learning and memorizing all the different types of terminology that's associated with informatics. Okay, hierarchical. I think one of my favorites is hierarchical because I work with in Epic is like the Chronicles database, which is hierarchical, and I think it's very easy, intuitive. It meets my needs pretty nicely. So hierarchical model organizes data into a tree-like structure where each record has a single parent or root. Sibling records are sorted in a particular order. That order is used as the physical order for storing the database. This model is good for describing many real-world relationships. And it's just like, it's very intuitive. And then whenever I think about building something in Epic, I usually think of things in that manner. How to group information, right? To make it scalable and intuitive. Makes sense. You're not just like building just to build. Network model. Let's see. The network model builds on the hierarchical model by allowing many-to-many relationships between linked records, implying multiple parent records. Based on mathematical set theory, the model is constructed with sets of related records. Each set consists of one owner or parent record and one or more member or child records. A record can be a member or child in multiple sets, allowing this model to convey complex relationships. It was most popular in the 70s after it was formally defined by the Conference on Data System Languages. So vendor has employee, customer, and product, and each of them can have a sales transaction. Interesting. Applying multiple parent records. Oh, this one, in the sense that sales transaction can have employee, customer, and product. I don't think this really makes that much sense to me, but I might look into that more later. Object-oriented database model. This model defines a database as a collection of objects or reusable software elements with associated features and methods. There are several kinds of object-oriented databases. A multimedia database incorporates media, such as images, that could not be stored in a relational database. A hypertext database allows any object to link to any other object. It's useful for organizing lots of disparate data, but it's not ideal for numerical analysis. The object-oriented database model is the best known post-relational database model since it incorporates tables, but it isn't limited to table. Such models are also known as hybrid database models. Sales report, product code goes to product code. Object one instance. This is interesting. I wonder if Notion is an object-oriented database model. So I'm like this going off of a tangent real quick. Is Notion an object-oriented database? Object-oriented database system. No, object-oriented. Yeah, I think it is. Very interesting. yeah, I use Notion quite often now to like organize different things all over my life, personal and professional. And you can link to other things and not limited to just numerical or like typical character types. You can link to images, files, things like that from one database. Really cool. If you guys haven't ever checked out Notion, it's a very awesome database that I use in both my personal and professional life. Okay, cool. So those are called object-oriented databases. Entity relationship model. This hybrid database model combines the simplicity of the relational model with some of the advanced functionality of the object-oriented database model. In essence, it allows designers to incorporate objects into the familiar table structure. Languages and call interfaces include SQL3, vendor languages, ODBC, JDBC, and proprietary call interfaces that are extensions of the languages and interfaces used by the relational model. Probably a little too complex and for my understanding in this case. It is probably not really necessary for this exam, but we'll include it anyway. Entity relational model. This model captures the relationships between real-world entities, much like the network model, but it isn't as directly tied to the physical structure of the database. Instead, it's often used for designing a database conceptually. Entity relationship. Here, the people, places, and things about which data points are stored are referred to as entities, each of which have certain attributes that together make up the domain. The cardinality or relationships between entities are mapped as well. A common form of the ER diagram is the star schema, ER, in which a central fact table connects to multiple dimensional tables. This is very interesting. Entity relationship. I feel like I've seen a lot of this used within Epic. Especially when it comes to like Slicer, Dicer, and Caboodle. This is interesting. I probably should learn more about this one. They talked about star schema and these other ones. Oh, there's other database models. I probably should capture this as just to be thorough. Star schema. Where is the, I don't see the other star schema. Other database models. So let me actually pull this over here and just type this up. Other database have been or are still used. So we have inverted file model, flat model, multi-dimensional model, semi-structured model, context model, associative model. The funny thing is, like, you know, it's sometimes it might be hard to think about how these might apply to real world situations, and I feel as though every time I'm tackling some type of problem or project when it comes to informatics, or like when I'm trying to do something in Epic, the first thing I do is usually try to think about some database and how to map all the relationships of how data connect using some type of, I guess, model in this case to answer questions. So I think it's good to know different ways of making relationships between data. It always just helps to solve the question or problem that you're trying to tackle. Maybe it makes more sense if you're actually working in informatics. Okay, let me go ahead and just cite this as, let me sign in. Database models. What is a database model? Yeah, that's it. Cool. I mean, again, I assume most of the people who are taking this exam probably know the various database models. This is just all review. I'm not going to cite the other one. I think this is fine. It's like unnecessary. I think we covered all of these anyways in the minus the snowflake schema. Yeah, that's fine. We can move on. Let's see. I think other database. Yeah, this is probably fine. So that was basic database structure. The next one, do data retrieval and analytics techniques and tools. Oh, that's not what I want to do. Data retrieval and what was it called again? Analytics, data retrieval and analytics techniques and tools. Analytics techniques and tools. I mean, is this like the programming languages? Was that what they're trying to get at? Data retrieval and analytics techniques and tools. Let's see what comes up. Yeah, so analytics is probably just the different languages. So analytics tools top 10. This might be a nice thing to cite. Growing demand and importance of data analytics in the market have generated many openings worldwide. It becomes slightly tough to shortlist the top data analytics tools, as the open source tools are more popular, user-friendly, and performance-oriented than the paid version. There are many open source tools which doesn't require any coding and manages to deliver better results than paid versions. Examples are like R programming and data mining, and Tableau Public, Python and data visualization. Below is a list of top 10 data analytics tools, both open source and paid, based on their popularity, learning, and performance. So it's good to be aware of these things. So why don't I go ahead and do top 10 analytics tools. I'll list all these. So we have R programming, Tableau, Public, Python, SAS, Apache Spark. I don't know if I've ever heard of that one. Excel's on here. I mean, probably shouldn't sell Excel short. I love Excel. Use Excel all the time. 9. One. Never heard of that one. Quick Lick View. Haven't heard of that one either. And then there is Splunk. Interesting. Okay. I don't. Yeah, maybe I'll just go ahead and copy this too. Let me cite this source real quick. So this is top 10 analytics tools. Go ahead and cite analytics tools. Okay. Go and copy all this. Good for reading pleasure. Again, whoever reads through this entire study guide, I would hope has a very solid chance of passing the exam, because this is a lot of information. Tableau Public. I didn't know there was a free version of Tableau. I thought it was always private. It's nice that there's a free one. Python. Object-oriented scripting. Okay. SAS. All right, paste without formatting. Here we go. Apache Spark. feel like I should go back and learn some of these languages, but it's a lot of work. Excel. But I feel like sometimes it's worth it, right? The sacrifice is worth it. At the end of the day, you know, some of these skill sets will really make you, and it'll pay off a lot in the long term. Your ability to be efficient and do things really pays it off. But I do think that the barrier to entry is quite high, especially for people who are new to computer programming languages. Collect view. Okay. Man, how long have we been streaming? 20 minutes. Okay. Moving on. Next one. Splunk. This is a very like uninteresting name. Splunk. Okay, cool. So we have the top 10. Good to know. I feel like the ones I always think about. You know what? I'm surprised like SQL is on there. Is SQL even considered like a analytics tool? I feel like data retrieval, maybe not analytics. R, Python, Tableau, SAS are the ones I probably think about. All right, data retrieval. This is there's no analytics techniques here, so this is. We might have to come back to that. Let me take a look at data retrieval. Data retrieval. Let's do that. Data retrieval. Big data retrieval. That's interesting. Information retrieval. Let's take a look at this. Data retrieval means obtaining data from a database management system such as ODBMS. In this case, it is considered that data is represented in a structured array and there is no ambiguity in data. In order to retrieve the desired data, the user presents a set of criteria by a query. Then the DBMS selects the demanded data from the database. The retrieved data may be stored in a file, printed, or viewed on screen. A query language, such as structured query language or SQL, is used to prepare the queries. SQL is an American National Standards Institute standardized query language developed specifically to write database queries. Each DBMS may have its own language, but most relational. Reports and queries are the two primary forms of the retrieved data from a database. There are some overlaps between them, but queries generally select a relatively small portion of the database, while reports show larger amounts of data. Queries also present the data in a standard format and usually display it on the monitor, whereas reports allow formatting of the output however you like and is normally printed. Reports are designed using a report generator built into DBMS. This is probably fine for the thing. So this just says data retrieval. So I wonder if they're trying to group. They're probably trying to do like data retrieval and analytics techniques. No, actually, I probably should break it up. Data retrieval. Let me do this. Actually. Tools. No, let's do that. I'm just gonna use this definition here. Data retrieval. I really like it. Nice, sweet, to the point. Oops. And cite. Citing Wikipedia. I'm assuming the test is not really going to test you on this definition, but maybe for people who just need a reinforcement of what data retrieval refers to. I'm assuming most of this is probably going to be like data analytical techniques. This is probably what they're referring to. We'll just go with this. Yeah, this looks pretty solid. Let's just go with this. Maybe we'll read through this and then we will, come on, let's close this. And then we'll read through it. Let me just type this part up. Regression analysis, analysis, Monte Carlo simulation, factor analysis, cohort analysis, cluster analysis, time series analysis, sentiment analysis. I think I cited this right. Let's see, like techniques. Yeah. Let's do that. All right. The site, yep. Let's read through it. Regression. Let me read this. Data analytics is the process of analyzing raw data to draw out meaningful insights. These insights are then used to determine the best course of action. When is the best time to roll out that marketing campaign? Is the current team structure as effective as it could be? Which customer segments are most likely to purchase your new product? Ultimately, data analytics is a crucial driver of any successful business strategy, but how do data analysts actually turn raw data into something useful? There are a range of methods and techniques that data analysts use depending on the type of data in question and the kinds of insights they want to uncover. In this post, we'll explore some of the most useful methods of data analysis. By the end, you'll have a much clearer idea of how you can transform meaningless data into business intelligence. The first 6 methods are for quantitative data, while the last technique applies to qualitative data. We'll briefly explain the difference between quantitative and qualitative data below. But if you want to skip straight to a particular analysis technique, just use the clickable menu above. Go ahead and put that in here. Okay. Regression analysis is used to estimate the relationship between a set of variables. When conducting any type of regression analysis, you're looking to see if there's a correlation between a dependent variable, that's the variable outcome you want to measure or predict, and any number of independent variables, factors which may have an impact on the dependent variable. The aim of regression analysis is to estimate how one or more variables may impact the dependent variable in order to identify trends and patterns. This is especially useful for making predictions and forecasting future trends. Let's imagine you work for an e-commerce company and you want to examine the relationship between how much money is spent on social media marketing and sales revenue. In this case, sales revenue is your dependent variable. It's the factor you're most interested in predicting and boosting. Social media spend is your independent variable. You want to determine whether or not it has an impact on sales and ultimately whether it's worth increasing, decreasing, or keeping the same. Using regression analysis, you'll be able to see if there's a relationship between the two variables. A positive correlation would imply that the more you spend on social media marketing, the more sales revenue you make. No correlation at all might suggest that social media marketing has no bearing on your sales. Understanding the relationship between these two variables would help you make informed decisions about the social media budget going forward. However, it's important to note that on their own, regressions can only be used to determine whether or not there's a relationship between a set of variables. They don't tell you anything about cause and effect. So while a positive correlation between social media spend and sales revenue may suggest that one impacts the other, it's impossible to draw definitive conclusions based on this analysis alone. There are many different types of regression analysis, and the model you use depends on the type of data you have for the dependent variable. For example, your dependent variable might be continuous, something that can be measured on a continuous scale such as sales revenue and USD, in which case you'd use a different type of regression analysis than if your dependent variable is categorical in nature, i.e. comprising values that can be categorized into a number of distinct groups based on a certain characteristic, such as customer location by continent. You can learn more about the different types of dependent variables and how to choose the right regression analysis in this guide. Okay. It's like solid. Let me go ahead and copy and paste this. Always good to use data to answer questions, which I guess what all these techniques are for. Okay, Monte Carlo. I'm most familiar with Monte Carlo in doing like in infectious disease simulations. All right, Monte Carlo simulation. When making decisions or taking certain actions, there are a range of different possible outcomes. If you take the bus, you might get stuck in traffic. If you walk, you might get caught in the rain or bump into your chatty neighbor, potentially delaying your journey. In everyday life, we tend to briefly weigh up the pros and cons before deciding which action to take. However, when stakes are high, it's essential to calculate as thoroughly and accurately as possible all the potential risks and rewards. Monte Carlo situation, otherwise known as the Monte Carlo method, is a computerized technique used to generate models of possible outcomes and their probability distributions. It essentially considers a range of possible outcomes and then calculates how likely it is that each particular outcome will be realized. The Monte Carlo method is used by data analysts to conduct advanced risk analysis, allowing them to better forecast what might happen in the future and make decisions accordingly. So how does this work? To run a Monte Carlo simulation, you start with a mathematical model of your data, such as a spreadsheet. Within your spreadsheet, you have one or several outputs that you're interested in. Profit, for example, or number of sales. You'll also have a number of inputs. These are variables that may impact your output variable. If you're looking at profit, relevant inputs might include the number of sales, total marketing spend, and employee salaries. If you knew the exact definitive values of all your input variables, you'd quite easily be able to calculate what profit you'd be left with at the end. However, when these values are uncertain, a Monte Carlo simulation enables you to calculate all the possible options and their probabilities. What will be your profit if you make $100,000 in sales and hire 5 new employees on a salary of $50,000 each? What is the likelihood of this outcome? What will your profit be if you only make $12,000 in sales and hire 5 new employees, and so on? It does this by replacing all uncertain values with functions which generate random samples from distributions determined by you, and then running a series of calculations and recalculations to produce models of all the possible outcomes and their probability distributions. The Monte Carlo method is one of the most popular techniques for calculating the effect of unpredictable variables on a specific output variable, making it ideal for risk analysis. All right. I don't think I've ever actually done a Monte Carlo simulation, but it seems like you just plug and play for the most part. Cool. Factor analysis. I don't know if I've ever heard of this one. Factor analysis is a technique used to reduce a large number of variables to a smaller number of factors. It works on the basis that multiple separate observable variables correlate with each other because they are all associated with an underlying construct. This is useful not only because it condenses a large data set into smaller, more manageable samples, but also because it helps to uncover hidden patterns. This allows you to explore concepts that cannot be easily measured or observed, such as wealth, happiness, fitness, or for a more business-relevant example, customer loyalty and satisfaction. Let's imagine you want to get to know your customers better, so you send out a rather long survey comprising 100 questions. Some of the questions relate to how they feel about your company and product. For example, would you recommend us to a friend? And how would you rate the overall customer experience? Other questions ask things like, what is your yearly household income? And how much are you willing to spend on skincare each month? Once your survey has been sent out and completed by lots of customers, you end up with a large data set that essentially tells you 100 different things about each customer, assuming each customer gives 100 responses. Instead of looking at each of these responses individually, you can use factor analysis to group them into factors that belong together. In other words, to relate them to a single underlying construct. In this example, factor analysis works by finding survey items that are strongly correlated. This is known as covariance. So if there's a strong positive correlation between household income and how much they're willing to spend on skincare each month, as one increases, so does the other, these items may be grouped together. Together with other variables, survey responses, you may find that they can be reduced to a single factor, such as consumer purchasing power. Likewise, if a customer experience rating of 10 out of 10 correlates strongly with the yes responses regarding how likely they are to recommend your product to a friend, these items may be reduced to a single factors such as customer satisfaction. In the end, you have a smaller number of factors rather than hundreds of individual variables. These factors are then taken forward for further analysis, allowing you to learn more about your customers. Oh, that's interesting. I didn't know there was like a technical term for that. I probably do this quite often. Like you just explore the raw data and see if you can identify different trends and then further group them into like, more related groups. Or I guess factors in this case. Cool. Factor analysis. I feel like it's not very like intuitive, the name of it. Cohort analysis is defined on Wikipedia as follows. Cohort analysis is a subset of behavioral analytics that takes the data from a given data set and rather than looking at all users as one unit, breaks them into related groups for analysis. These related groups or cohorts usually share common characteristics or experiences within a defined time span. So what does this mean and why is it useful? Let's break down the above definition further. A cohort is a group of people who share a common characteristic or action during a given time period. Students who enrolled at university in 2020 may be referred to as the 2020 cohort. A customer who purchased something from your online store via the app in the month of December may be considered a cohort. With cohort analysis, you're dividing your customers or users into groups and looking at how these groups behave over time. So rather than looking at a single isolated snapshot of all your customers at a given moment in time, with each customer at a different point in their journey, you're examining your customer's behavior in the context of the customer life cycle. As a result, you can start to identify patterns of behavior at various points in the customer journey, say from their first ever visit to your website, through to email newsletter sign up to their first purchase and so on. As such, cohort analysis is dynamic, allowing you to uncover valuable insights about the customer life cycle. This is useful because it allows companies to tailor their service to specific customer segments or cohorts. Let's imagine you run a 50% discount campaign in order to attract potential new customers to your website. Once you've attracted a new group of customers or cohort, you'll want to track whether they actually buy anything, and if they do, whether or not and how frequently they make a repeat purchase. With these insights, you'll start to gain a much better understanding of when this particular cohort might benefit from another discount offer or retargeted ads on social media, for example. Ultimately, cohort analysis allows companies to optimize their service offerings and marketing to a more targeted, personalized experience. This makes sense. I feel like people probably do this quite often. Cohort analysis. These are like things we probably all do in informatics, and we just, or I didn't realize there were like formal names for this. Cluster analysis. Cluster analysis is an exploratory technique that seeks to identify structures within a data set. The goal of cluster analysis is to sort different data points into groups or clusters that are internally homogeneous and externally heterogeneous. This means that data points within a cluster are similar to each other and dissimilar to data points in another cluster. Clustering is used to gain insight into how data is distributed in a given data set, or a pre-processed step for algorithms. There are many real-world applications of cluster analysis. In marketing, cluster analysis is commonly used to group a large customer base into distinct segments, allowing for a more targeted approach to advertising and communication. Insurance firms might use cluster analysis to investigate why certain locations are associated with a high number of insurance claims. Another common application is in geology, where experts will use cluster analysis to evaluate which cities are at greatest risk of earthquakes and thus try to mitigate the risks with protective measures. It's important to note that while cluster analysis may review structures within your data, it won't explain why those structures exist. With that in mind, cluster analysis is a useful starting point for understanding your data and informing further analysis. Clustering algorithms are also used in machine learning. I definitely do that too. Cluster analysis. Okay. Time series. This is a lot of reading. Time series analysis. Okay. Time series analysis is a statistical technique used to identify trends and cycles over time. Time series data is a sequence of data points which measure the same variable at different points in time. For example, weekly sales figures or monthly email signups. By looking at time-related trends, analysts are able to forecast how the variable of interest may fluctuate in the future. When conducting time series analysis, the main patterns you'll be looking for in your data are trends, stable, linear, increases or decreases over an extended time period, seasonality, predictable fluctuations in the data due to seasonal factors over a short period of time. For example, you might see a peak in swimwear sales in summer around the same time every year. Cyclic patterns, unpredictable cycles where the data fluctuates. Cyclical trends are not due to seasonality, but rather may occur as a result of economic or industry-related conditions. As you can imagine, the ability to make informed predictions about the future has immense value for business. Time series analysis and forecasting is used across a variety of industries, most commonly for stock market analysis, economic forecasting, and sales forecasting. There are different types of time series models depending on the data you're using and the outcomes you want to predict. These models are typically classified into three broad types: the autoaggressive models, the integrated models, and the moving average models. For an in-depth look at time series, refer to this. Cool. Very useful. I think the first thing that comes to mind is like flu season. You know, you see when people are getting sick. But, I mean, we already know the typical flu season, so I guess we don't really need to do a time series analysis on that. But this came to mind. Sentiment analysis. When you think of data, your mind probably automatically goes to numbers and spreadsheets. Many companies overlook the value of qualitative data. And in reality, there are untold insights to be gained from what people, especially customers, write and say about you. So how do you go about analyzing textual data? One highly useful qualitative data is sentiment analysis, a technique which belongs to a broader category of text analysis, the usually automated process of sorting and understanding textual data. With sentiment analysis, the goal is to interpret and classify the emotions conveyed within textual data. From a business perspective, this allows you to ascertain how your customers feel about various aspects of your brand, product, or service. There are several different types of sentiment analysis models, each with a slightly different focus. The three main types include fine-grained sentiment analysis. If you want to focus on opinion polarity, positive, neutral, negative, in depth, fine-grained sentiment analysis will allow you to do so. For example, if you want to interpret star ratings given by a customer, you might use fine-grained sentiment analysis to categorize the various ratings along a scale ranging from very positive to very negative. Emotion detection. This model uses complex machine learning algorithms to pick out various emotions from your textual data. You might use an emotion detection model to identify words associated with happiness, anger, frustration, and excitement, giving you insight into how your customers feel when writing about you or your product on, say, a new product review site. Aspect-based sentiment analysis. This type of analysis allows you to identify what specific aspects the emotions or opinions relate to, such as certain product feature or a new ad campaign. If a customer writes that they find the new Instagram advert so annoying, your model should detect not only a negative sentiment, but also the object toward which it's directed. In a nutshell, the sentiment analysis used in various natural language processing systems and algorithms, which are trained to associate certain inputs, for example, certain words with certain outputs. For example, the input annoying would be recognized and tagged as negative. Sentiment analysis is crucial to understanding how your customers feel about your products, or for identifying areas for improvement, and even for averting PR disasters in real time. Good to know. Okay. I think that might be the last bit. So this was analytical techniques, so we're good on that. Okay. I think that was it for section 8. Oh, it was a good amount. Wow, man, 44 minutes too. Okay, so we're gonna move on here. And then the next piece was section 9, which gonna take a quick break. Get some water. Be right back. Basic systems and network architectures. What are we getting at here? Systems network architecture. I'm just gonna take a look at this Wikipedia. Systems network architecture is IBM's proprietary networking architecture, created in 1974. Protocol stack for interconnecting computers and their resources. SNA describes formats and protocols and is in itself not a piece of software. Implementation of SNA takes the form of various communication packages, most notably Virtual Telecommunications Access Method, the mainframe software package for SNA communications. Is this what their systems? Interesting. Oh, wait. Is there more in there? Very technical things that they're asking that we know. What is systems network architecture? Networking file-level design architecture. This is a little too technical for me. Basic systems and network architectures. This is also IBM. Is there anything else? Types of network architecture. Basic systems and network architecture. So, network architecture is the logical and structural layout of the network, consisting of transmission equipment, software, and communication protocols and infrastructure, wired or wireless transmission of data, and connectivity between components. The two types of widely used network architectures are peer-to-peer, aka P2P, and client/server, aka tiered. I think this is what they're going for. Peer-to-peer architecture. In a peer-to-peer network, tasks are allocated to every device on the network. Furthermore, there is no real hierarchy in this network. All computers are considered equal and all have the same abilities to use the resources available on this network. Instead of having a central server which would act as the shared drive, each computer that's connected to this network would act as the server for the files stored on it. Peer-to-peer network. Okay, makes sense. Advantages of peer-to-peer. It does not require a dedicated server, which means it's less costly. If one computer stops working, the other computers connected to the network will continue working. Installation setup is quite painless because of the built-in support in modern operating systems. Disadvantages. Security and data backups are to be done by each individual computer. As the numbers of computers increase on a P2P network, performance, security, and access becomes a major headache. Client-server architecture. Architecture of computer network in which many clients, remote processors, request and receive service from a centralized server. In a client-server network, a centralized, really powerful computer or server acts as a hub in which other computers or workstations can connect to. This server is the heart of the system, which manages and provides resources to any client that requests them. Advantages. Resources and data security are controlled through the server, not restricted to a small number of computers, and servers can be accessed anywhere and across multiple platforms. Disadvantages. It can become very costly due to the need of a server as well as networking devices such as hubs, routers, and switches. If and when the server goes down, the entire network will be affected. Technical staff needed to maintain and ensure network functions efficiently. Oh, this is the one we're looking for. This is probably like simple enough. So there's two types. Let me go ahead and basic systems. I don't know if we need anything. The two most widely. We'll do peer to peer P2P, P2P, and then client server, aka tiered. defining network architecture. Let's go ahead and do this. Okay. Go ahead and paste this. Oops. Advantages and disadvantages. Paste. Disadvantages. Just would do one more search. I think this might be good. This is like pretty short. I don't know if we really need to know too much more than this. Or maybe, I don't know. This is always good, like when knowing this kind of systems architecture, when servers go down and stuff, you like have a better idea of like where the problem is, so you can troubleshoot effectively as an analyst or as a leader, how you design certain systems, knowing the disadvantages and advantages. Advantages, copy and paste. And disadvantages. Okay. Let me just do one more search to see if there is, did I cite this? Not yet. Let me go ahead and cite. What is this one called? Types of network. Okay, while I was doing that, let me do one more search. This was a network architecture. What is this? Previous section established pretty substantial requirements for network design. A computer network must provide general, cost-effective, fair, and robust connectivity among a large number of computers. As if this weren't enough, networks do not remain fixed at any single point in time, but must evolve to accommodate changes in both the underlying technologies upon which they are based, as well as changes in the demands placed on them by application programs. Furthermore, networks must be manageable by humans of varying levels of skill. Designing a network to meet these requirements is no small task. To help deal with this complexity, network designers have developed general blueprints called network architectures that guide the design and implementation of networks. This section defines more carefully what we mean by network architecture by introducing the central ideas that are common to all network architectures. It also introduces two of the most widely referenced architectures, the OSI, the 7-layer architecture, and the internet architecture. Okay, maybe it was oversimplification to just assume it was maybe just those two. I mean, there is peer-to-peer in this one. So layering and protocoling. Abstraction, the hiding of implementation details behind a well-defined interface, is the fundamental tool used by system designers to manage complexity. The idea of an abstraction is to define a model that can capture some important aspects of the system, encapsulate this model in an object that provides an interface that can be manipulated by other components of the system, and hide the details of how the object is implemented from the users of the object. And challenges to identify abstractions that simultaneously provide a service that prove useful in a large number of situations and that can be effectively implemented the underlying system. This is exactly what we were doing when we introduced the idea in the previous section, providing an abstraction for applications that hides the complexity of the network from application writers. Computer systems, a system approach. Layered network system. So that must be another type of network. Application programs, process to channels, host to host. Layering. Layered systems with alternative abstractions available at a given layer. Peer-to-peer. Yeah, this is probably like a good thing to cite. Problem with all this material is it gets, I love this stuff, but it gets a bit mundane. Quite a bit, especially if like it doesn't impact you directly as much. I mean, it does, but it doesn't at the same time. It's just a lot of information. This is probably really good to know about. I really want to use this. I think this one might be important. The 7-layer OSI model. The ISO was one of the first organizations to formally define a common way to connect computers. Their architecture, called the Open Systems Interconnection Architecture, an illustration in Figure 13, defines a partitioning of network functionality into 7 layers, where one or more protocols implement the functionality assigned to a given layer. In this sense, the schematic given in Figure 13 is not a protocol graph per se, but rather a reference model for a protocol graph. It is often referred to as the 7-layer model. While there is no OSI-based network running today, the terminology it defined is still widely used, so it is worth a cursory look. Yeah, I think this is actually, I said that about the other one at first. This is probably part of it. Internet architecture, I know that they commonly reference this quite often in a lot of my informatics readings. OSI I've heard about before, so it probably is important to read this. You know what, I'm probably gonna cite these other two, and then we're just and call this a day. Let me just do the 7-layer. Go ahead and do this. Basic systems. So I'm gonna do here peer-to-peer, and then we're gonna do, where did it go? Here we go. Seven-layer OSI model, and then the other one was, I think, internet architecture. Let me edit this. So this other one was called architecture. I think it was this one. Cool. I feel like the HIMSS exam probably includes a lot of this. I remember like seeing the HIMSS material and seeing them reference a lot of this stuff. Okay. Go ahead and paste this. Oh, this is a lot. Probably want to paste their picture for the OSI model too, so save image. Let's do OSI model. All right, insert image. Western here, OSI, nice. Okay, now let's go towards internet architecture. I probably should be reading this, but we're about to hit, we already hit the 1 hour mark, so I'm gonna call it a day here. At some point, once all this whole study guide is done, I'll come back and review all of this information, which is going to be a lot. Save image. This is internet model. Go ahead and insert image. Cool. And copy the rest of this. paste. Okay, I think we're good here. Whew, that was a long section. Okay, and I think I cited both of these already. Yep. I should probably be doing more of these to be more comprehensive. Yeah, I'm gonna try to do this whenever I can, so it's well referenced. All right, guys. So this is section 8 and 9. Both of these are done. Let me just double check here. Yeah, 8 and 9. Basic database structure, retrieval analytics tools, and then basic systems and network architectures. I'm gonna take another break, and then I will start section 10 and 11 in maybe another hour or 2 hours from now. Thank you guys for tuning in. See you guys in the next stream. Bye.